Automobile and IC Engine Workshop. This workshop is designed to provide an insight to the basics of vehicle dynamics, IC engine working, and various other automobile engineering aspects. So, in simple words, if I define automobile, it's a wheeled vehicle that carries its own motive power unit, that is, its engine, and is used to transport people and items from one location to another. It is also known as self-propelled vehicle because it produces power within itself for its propulsion, generally driven by IC engine. Some examples can be cars, buses, trucks, tractors, etc. Coming to the history of automobile, the original idea of automobile cannot be attributed to one single individual. Most historians agree that Nicolas Joseph Cugnot of France was the constructor of the first true automobile. Cugnot's vehicle was a huge, heavy, and steam-powered tricycle, and his model of 1769 was said to have run for 20 minutes at 3.6 km per hour while carrying 4 people and to have recuperated sufficient steam power to move again after standing for 20 minutes. Carl Benz was a German mechanical engineer who designed and built the world's first practical automobile to be powered by an internal combustion engine. In 1886, he drove the first automobile in Mannheim, Germany, reaching to a top speed of 16 km per hour. The automobile was powered by a 0.75 horsepower, one cylinder, two stroke gasoline engine. This was the day the automobile was born. 1886 was marked the beginning of the so far 130-year-long success story of Mercedes-Benz. Automobiles can be classified into several types based on many criteria, such as on the basis of purpose, they can either be used for carrying passengers, example cars, buses, or for goods, example trucks. On the basis of fuel used, petrol vehicle, example motorcycle, scooter, diesel vehicle, example trucks, buses, electric vehicle, which use battery to drive, steam vehicle, that is an engine that uses steam engine, but these engines are now obsolete. And today we also have gas vehicle, example LPG and CNG vehicles. Similarly, we have automobiles classified on the basis of construction, drive, and body. An automobile has several number of parts, but there are 4 to 5 essential components of automobile. Engine, which is the source of motive power to an automobile. Transmission system consists of clutch, gearbox, propeller shaft, axle, a control system such as brakes and steering, and is used to transmit power from the engine to the wheels.
We will be going through chassis functions and needs and then types of chassis. Then we will learn about design objectives and optimization. What affects the chassis design and all the types of simulation that is needed to be performed. You must be watching this workshop session in some electronic device. Maybe it's a laptop or smartphone. You can see the phone chassis here, okay, in the right side of the screen. What chassis we are doing is it is holding components like screen, battery, sim panel, camera, and more. The same thing goes with a drone and an actual car as well. Just the difference in a car chassis, there are lots of static and dynamic loads involved in the case of automobile. The most primitive type of automobile chassis is a backbone chassis. You can see there is a single beam and it's pretty much clear why the name is backbone. It does not require a very high-end manufacturing solution because of its design simplicity, and that's what makes it easily producible. But yes, the major drawbacks are its low stiffness and safety concerns. Like you can see its disadvantages. And then comes the ladder chassis. It has two long beams with transverse beams. Like you must have seen trucks or buses, so they use this type of chassis, and beneath the whole body they have this type of frame. Okay, so the transfer beams are there to help in mountings and increase its stiffness. Ladder chassis is known for its high bending stiffness, and this is why it's widely used in heavyweight vehicles. Then comes the space frame chassis. This is basically formed by welding metal tubes to make a space truss kind of thing. Its torsional stiffness is better as compared to the previously shown chassis, like ladder chassis and the backbone chassis. Now comes the monocoque and unibody chassis, which is basically like a single shell kind of thing. carbon fiber monocoque is famous in the racing sector. Its stiffness to width ratio is highest amongst all the chassis we looked upon. And the advantages you can see, it provides a good safety, and yes, its disadvantage is it is very highly expensive. So here you can see the first ever carbon fiber monocoque chassis that was made by McLaren, and they went on to win the British Grand Prix that season with this. So you can think how efficient this type of chassis is. So basically, torsional stiffness is all about the resistance of the chassis to twisting, like when you twist something. Like here in the first figure, you can see a ladder chassis with no triangulations or crossbars. So this is the least stiff, and then you can see this one. It has a crossbar, so its torsional stiffness has increased. And then there is a third one with the triangulation in the cockpit region. So its stiffness is the largest. Now let's understand the mathematical interpretation of torsional stiffness. It's basically torque upon angular deflection. You can see in this figure that the rear end of the chassis is fixed, and we have attached a beam to apply a load, okay, which will eventually be converted into torque due to its eccentricity. We know load value, we know beam length, and torque is a length into force. So we have the torsional stiffness as P multiplied by L and then divided by the twist angle. And then comes the very famous golden ratio, which is stiffness divided by mass. We want the stiffness to increase and we want the mass to decrease, which will eventually increase the golden ratio. So we can basically compare the chassis iterations using this golden ratio comparison. So basically you have understood what this is. We want this to increase and we want this to decrease. So the whole fraction will increase. So suppose you are in 1950, and that means you don't have any CAD or simulation software packages. You just have a pen and a notebook. Okay. And you have to design a backbone chassis with a single beam. So first of all, I will want to know from you guys, like, what do you think you have to design in this chassis? Like, if I tell you that you have to design this backbone chassis, then what parameters will you design? What things are you going to design? It's basically resonating at its natural modes. Like maybe this is the mode 1, this is mode 2, this is mode 3, this is mode 4. So you have to calculate it's the first mode of this backbone chassis, and you have to know like on what natural frequency is this chassis going to vibrate. Like,
basic unit of suspension is to isolate the vehicle from disturbances so that the driver can keep control of vehicle without causing discomfort to passengers. It minimizes the vertical motion as well as pitch and roll movements as the vehicle passes over irregular roads. And it provides a good level of comfort for passengers. Mainly, suspension mein there are three words of paramount importance. That is, there are 3 C's, which are control, comfort, and contact. The driver should always have the control of the vehicle. The tire should always be in contact with the road, and the passengers and driver should always be in comfort. Now let's start with the basic terminologies of the suspension. That is camber, caster, and toe. Camber is the inward or outward tilt of the front tires as seen from the front. Like, seeing from the front is the most important term for camber. Camber can only be seen from the front. It is the inclination of the steering axis from vertical. This is the caster when seen from the side. Side view for caster is paramount. It is important to note it can be only seen from side view. Caster from side view, camber from front view. Toe is the side to side difference between the front of a wheel and the rear of a wheel. Shock absorbers. As the name suggests, absorbs road shocks or impacts due to bump in road by oscillating, reduce the tendency of carriage or car to continue to bounce up and down on its spring. Now there are 2 things, or basically say 3: spring, damper, strut, and shock absorber. Tires are one of the most, they are the most important part of a vehicle. Now we come to the notation of tires. First of all, this is the section width, the width in mm. Okay, this is the width of a tire, that is 195. The number adjacent to it, 55, is the aspect ratio. That is this height upon the width of tire. This is the aspect ratio. Then we come on to construction, which is radial or bias B. Then we come on to load index. This is what differentiates the tires between the truck, cycle, and a car.